The next section of the notes, you need to know how to find the multiplicity of a 0. Step 1, factor. Step 2, set them equal to 0 and solve. Step 3, to see what the multiplicity of 0 is, here you go. If you get the same answer twice, it has a 0 multiplicity of 2. If you get the same answer 3 times, it has a 0 multiplicity of 3. If you get the answer once, it's a 0 multiplicity of 1. Whew! That's a mouthful, isn't it? So what we want to do is we want to take a look at the example that they give us. And we have f of x, or y, equals x to the 4th, yada, yada, yada. Now you see how it says x to the 4th? Because it's x to the 4th, it should have 4 zeros. It should have 4 zeros, okay? So what we're going to do is we're going to check it out to the best of our ability. So let's factor this. Step 1, take out a GCF of x squared. So you're left with x squared minus 2x minus 8. Next, factor it more. So you get x minus 4, x plus 2. Alright, step 1 is factor. Step 2, set each of these equal to 0. So we're going to set x squared equal to 0. We're going to set x minus 4 equal to 0. And x plus 2 equal to 0. And now we need to solve. Remember on this one, when you take the square root, you usually use plus and minus 0. But really there is no plus and minus 0, it just is 0. Over here you add 4, so x equals 4, and over here you add x equals negative 2. So can you see how this plus and minus here, it kind of quote-unquote happens twice, if you want to say it, okay? What we're going to write is we're going to talk about these different zeros. So, this happened twice. I'm going to put that in quotes. This happens 2 times, okay? And what happens 2 times? 0 happens 2 times. So it has what we call a 0 multiplicity of 2, because 0 happens at plus and at minus. Alright, x equals 4 happens once. So what we're going to do here, and here I'll put it the same, we'll keep it everything the same. This happens 1 time. So if 4 happens 1 time, we say it has a 0 multiplicity of 1, because it happens once. And let's keep moving on. See how x equals negative 2? This happens 1 time. So it as well has a 0 multiplicity of 1, because it happens once. So how many ever times it quote-unquote happens is what you say its 0 multiplicity is. Now count these. 1, 2, 3, 4. Didn't I tell you at the beginning it should have 4 zeros? That's because 0 happens twice, 4 happens once, and negative 2 happens once. We'll do the got it together in class. Unless you want to try it, you should get 3 different multiplicities. Next, if the graph of a polynomial function has several turning points, the function can have what we call a relative maximum, and it can have a relative minimum. A relative maximum is the value of a function at an up to down turning point. The relative minimum happens at a down to up turning point. We're going to learn how to use a calculator. In calculus, you're going to learn how to do these with these items that we call derivatives. Alright, we're not there yet, that's for sure. But these little turning points, these minimum and maximums, they're going to be so important to you come calculus. Alright, so here's your steps for your calculator. Let's just jump straight to number 5. We've got this equation. Now what I want you to notice is, do you see this is a cubic You should be able to eye that up right away. This is a cubic. It might have, let's write that down. It may have 2 turns. You should remember that from yesterday. Let's plug it in and see what the graph looks like. Your calculators are going to be your best friends in Chapter 5, guys. Alright, so I'll move that up there. Let's get it a good spot so you don't have a glare. That looks pretty good. So x cubed plus 3x squared minus 24x. Alright, let's graph this thing and see what we're dealing with. We've got a cubic. Now, you can see I kind of need to zoom out. So I'm going to hit zoom, select number 3, and hit enter so I can actually see this graph a little better. Still need to make it a little taller. So what I'm going to do is I'm going to zoom back in. I'm going to go back to the original. I like how wide it is. I'm just going to make it taller by selecting window. Let's make our y maximum. Let's go up to 30 and let's go down to negative 30. Let's see if that does. Not quite. I'm going to make this even taller, and this is a practice that you guys are going to have to do. I'm going to change my window to make it taller. I'm going to go all the way up. Let's try 90. Let's see how that goes. Still not quite high enough, is it, guys? Alright, just a little bit more. How about we make it 100 tall? Oh, you know what? I didn't change that part. Let's see. Did you see what I just did? I made a mistake here. Let's make the y. Let's make it go up to 90. There. Take a look at my. That's much better. Y max 90. Y scale 1. Let's see. That looks really good. I have a really nice graph. Now my y-axis is really stretched, but that's okay. Now as I point at this point right here, do you see this turning point? I want you guys to be able to write if that's a min or a max. So go ahead and on the paper, I want you to write min or max. I hope you had the time. That is a maximum. Let's use our graphing calculators and figure out what the heck that maximum point is. Watch carefully. Write some steps down, everybody. Okay, what you're going to do is you're going to hit second, trace. Since this is a max, you select number 4. Now what we need to do is find your cursor. It asks you to go to the left of the turning point. So I am to the left. I will hit enter. Now it wants me to go to the right. I'm going to hit enter now. Can you guys see those 2 little triangles? It's saying, okay, it's between here. It's asking me to take a guess. For everything considered, don't ask me why your calculator does this. The maximum is negative 480. Okay, I know it has a whole bunch of 9s after it, but I know it's negative 4. Sometimes your calculator is just weird like that. But your maximum is negative 480. Plug it in and prove it. That at that particular point, it is what we call and I should probably put that, a relative maximum. Now you guys see that thing down there? That's going to be a relative minimum. Let's use our calculators and figure out what it is. Second, trace, write these steps down. This time a minimum, number 3. Now I gotta find my cursor. See here, we want to go to the left of the minimum. That's pretty good. That's the left. Hit enter. Go to the right of the minimum. That's pretty good. Take a guess. And look at where your minimum occurs. It occurs at 2, negative 28. So you might want to replay those videos if you want to go ahead and write some steps down for your calculator. But your calculator is going to help you find the relative minimum and maximum. And trust me, when you get to calculus, if you can remember this little hint on your calculator, you'll really be able to double check yourself really well. Alright, moving on. We only have one more problem to do because we're going to do the got it's together in class. And that is problem 6. And we want to maximize volume on problem 6. Alright. The design of a digital box camera minimizes the volume while keeping the sum of the dimensions at 6. If the length must be 1.5 times the height, what should each dimension be? What we're going to do is we're going to write down some formulas we know. We know, like, for example, volume is equals length times width times height. And now what we're going to do is we're going to write down one more formula. It says the sum of the dimensions. Well, do you guys know what the word sum means? It means addition. So it's saying that the length plus the width plus the height will be 6. So these are two very key problems for you. Well, now what we have to do is read a little bit more, because it says the length must be 1.5 times the height. So we have three very important equations here for us. So what we're going to do is I'm going to put a little box around these because these are going to be important. The goal is to, it says, wants to maximize the volume. The goal is to maximize the volume. Now what we need to be able to do is get all of these in one variable. Can you see how length might be the easiest one for us to solve for? Or maybe even height? Let's try that. Let's try to get everything in terms of h. So what I'm going to do is I'm going to write volume equals length times width times height. Now let's take a look at the length. We can already replace the length with 1.5h. That's good. We want that to happen. And, well, while we're in terms of h, why don't we just bring h down? Now, who's clever enough to solve for w? That is going to come from, let's label some steps. This would be step number 1. This would be step number 2. And I would have to say that step number 3 would come from that particular equation that I drew my arrow from. Now, if you know length plus width plus height equals 6, I hope that you can agree with me that 1.5 height, because that's what length is, plus width plus height equals 6. Can you see what I did there? I just changed length to 1.5h. Alright, now check this out. I hope you agree with me that that is really w plus 2.5h equals 6. And now I hope that you agree with me one more step, that w could be written as 6 minus 2.5h. Okay, so what we're doing is we're writing everything in terms of h. So here's my step number 4. Okay, step number 4 is taking this and putting it in for w. Now that we have all of our items, we have our length, our width, and our height now in terms of h, let's write that down, all using h. That was the goal. We can put this into our calculator. So we have volume equals, big volume equals. Let's get our calculators and see if we can find the relative maximum on calc. Because remember, that was the goal. That would be step number 5. Okay, here we go. We'll go in there, we'll clear out what we have, and let's type our equation. Parenthesis 1.5h. We're going to have to use x, everybody, because we don't have an h. 6 minus 2.5x, or again, we have to use x because we don't have an h, times another x because we don't have an h. So we have it in our calculator. Let's hit, you guys remember how to get your normal window by hitting zoom 6? Let's check out if that's a good enough graph or not. Yeah, that's not too bad. You can see that your maximum is right here. Can you see that arc? Let's find what that value is. We need the maximum, number 4. Let's go to the left of it and hit, there it is, hit enter. Go to the right of it, hit enter, and take a guess and hit enter. There we go. We have our maximum at 1.6 and 7.68. Our maximum occurs at 1.6, 7.68. Now you might wonder, what the heck does that mean? 1.6 is the length, or excuse me, 1.6 is our variable. It is the height. and 7.68 is the volume. So I know I'm really struggling to find a lot of room here, aren't I? Let's go ahead and put everything in here. We know that the height has to equal 1.6, and what units are we in? Inches. We know that the length is 1.5 times that answer. I know I'm writing super small. So 1.5, I gotta use my calculator, times 1.6 is 2.4 inches. The last one we need to find is the width. The width we found was 6 minus 2.5 h, or since in this case h is 1.6, 6 minus 2.5 times 1.6. So 6 minus 2.5 times 1.6. My answer is 2 inches. And now you might be wondering, what the heck are these values again? These values are the dimensions to maximize the volume. And we had to use our calculator. We found our equation, we found our maximum, we were able to plug it in. Now if you're wondering how that 7.8 actually works, here's how it works. If you take 1.6 times, which is the height, 2.4, which is the length, times 2, look how we get that 7.68 that we were looking for. So it's actually kind of neat how all of this works. So the maximum volume is 7.68, and the dimensions are 1.6, 2.4, and 2 inches.